So yeah, thanks everyone for coming, and thanks Ben, Beth, and Bruno for organizing the event, and thanks to Checkout for having us here. So today's talk is not this serious. Actually, it's more about how we did this thing ourselves, and hopefully something we can share with you. So it's not really asking anyone to take control of anything. Right. So a little bit about myself. So I am a tech lead at Trinny London. We are an online makeup and skincare retailer. So I have been doing full stack engineering for like 10 years, almost 10 years. And I recently acquired the AWS Certified Solution Architect certificate. I am a huge Go fan and evangelist. I've been using Go since 2017. That's before Go module came out, basically. And I'm also enthusiastic in TypeScript and Rust. So please feel free to check out my social links. Yeah. Right, so that's all about me. And we can start the main topic. So I think microservice, we have no doubt that microservice is the main architecture most companies will adopt these days when building out their IT system. And usually it starts out like the one on the left. The design looks really shiny and pretty. And the reality is like that. So in one word, it's a mess. Yeah. So why this happens? It's because these are the problems that we need to solve before you can have a proper microservice architecture. Usually it's to do with how you manage the APIs. So the first thing is how you define the APIs. So what language do you define them in? Like you can use JSON, or you can use YAML, or you can use a more like a strictly checked language to do that. And I will show you the one we picked. The second is documentation. So where are the docs, where to find them? And most importantly, how do you ensure the docs are up to date with your code? Because if it's not up to date, it can do more harm than helpful, actually. And the third one is versioning. And this is very important as well, because how do you ensure that you can iterate your APIs without breaking your existing users? Dependencies. If you have a microservice architecture, how do you ensure you know what is calling what? Like the interconnection between the services, if you don't have a map like that, you can easily get lost. And again, bugs and toil-free. You don't want to be handcrafting your API layer again and again by hand, because that's just boring. And when you are bored, you tend to make bugs as well. And finally, consistency. How do you make sure that your microservice architecture looks consistent overall, instead of like having a zoo of microservices that each look different to one another. Yep. Right. So this is more about the concept of tech governance, and this is something that we embrace in our company as well. We identified 3 areas in tech that will help you make good decisions in the future, basically. So this is not specific to API management, but to anything you do in tech, basically. So the first one is a strategy. So strategy is looking into the future, to plan for the future. And usually that means acquire enough business knowledge and also do R&D to prepare for the things that is coming up in the business, basically. And secondly is the standard. You need to have a good standard in your tech department to make sure that everyone follows it. Otherwise, you will get like inconsistencies across everything. And then finally, automation is to remove the human factor, because by removing the human factor from your process, you can invest your developers into doing more interesting things. Yeah. Right. So now we can finally talk about code generation. So this is the landscape in the code generation / API world. These are the different tools that you can use to build out your API layer. I think this Apache Thrift and Avro, they are kind of a bit old. GraphQL is the I think it's probably one of the hottest tools these days. And then the one next to it is probably OpenAPI. And you also get AWS API Gateway and Protobuf, which is backed by Google. And I recently found a very interesting tool called Q. I don't know if anyone has checked it out. I think someone did a good talk on that recently, actually, on the tooling. Yeah, and I'll be very excited to check it out as well. Right, and the one we settled with was Protobuf. So the reasons we chose Protobuf is it's got very clean syntax, very good tooling. I'm not going to read everything through, but you can guess that the main reason is because it's like battle tested and it's open source and it's free for everyone to use. Right. So, but there's one thing that I want to just highlight is that we are not using gRPC. Well, we actually started out using gRPC, but we phased it out now, and we are fully REST. There are several reasons. The main reason is the language support for gRPC varies a lot. So C++ and Golang has very good support, but languages like JavaScript is a little bit lacking in terms of both the documentation and also its performance. So that ties back to number 3. So the performance impact is that because gRPC is a encoded language, it's a binary format on the wire, the encoding and decoding process can take a lot of CPU. And because JavaScript, Node.js, as we know, is single-threaded, if you spend too much time on the CPU, it can't process real business logic. And infrastructure support, gRPC is on HTTP 2, which means it needs a long-lasting TCP connection. And usually that goes against some of the load balancers, for example, which only balances at the HTTP level. Then that can cause issues as well. And finally, we are just not Google. So we just don't find the need to actually use something this high performant. Like pure REST works fine for us. So we just use pure REST. And I don't know if you can see this diagram, but this is the architecture we have. And I think this is also the architecture that most code generators will have these days, is that you have a centralized repository. I don't know if you can see this one. It's this one here, the API Def. That's where we keep all of our Protobuf, i.e. our API definitions in. And then we built out a CLI tool called API CLI. That takes in the API Def as input. And also in each microservice, we have something called a API spec. That defines basically which service you are trying to generate the code for. And then together that will generate the code, and it's better to ignore that because you don't want to check that in, because if you check that in, it gets out of date. So you want to regenerate your code in the CI environment again. And then we also built a shared libraries. It's called platform utils for different languages. And then the generated code, we use that, basically. And finally, this thing, together with the business logic, is packaged into the Docker container that's deployed in Kubernetes, for example. Right. This is a big debate we had when we were doing this thing, basically. Why we want to centralize the API definitions? Why not having each service owning its own API definition? And we decided that it's because service implementing the API doesn't mean the service owns the API. And this is a very important concept. I've seen just too many times that development teams own their API and they think that it's their own property, so they can do anything they want in there. Which is not true, because API definition is actually shared by the whole engineering team. It's not just the service that implements it, but also the users. Yeah. And also it makes versioning easy. It also means there's a single source of truth, so you're unlikely to get conflicts. Right. And this is how we build it. So it looks a little bit complicated, but it's actually not too bad. So the API CLI is in this yellow box there. So that has two parts. There's a Docker container in there, which we put all of the executables in there. The reason we use Docker is because we want this tool to run in different platforms. So in whether it's Windows or MacBook, if you package everything in the Docker container, it's agnostic. And then we build a wrapper on top of that to just run commands in the Docker container. And that we have host volume mapping, so the generated code can be written to the disk. This Docker container can also run inside Circle CI. So that means we can generate the code in the CI environment. And this is a snippet of the code, of the Protobuf definition. I think I won't go into too much details in here, but we invented our own annotation system that also helps with the generated code to say whether something is required or not. Yeah, we are not using the Protobuf defaults because they require extra packages to work. So we just invented our own annotations. Finally, a very important concept is reproducibility. To achieve this, we basically version everything. So API Dev is versioned using Git tags. Then we have the service version, the API version, and the API CLI itself also has a release version. If you get all these 4 versions fixed, then your code the generated code is guaranteed to be the same no matter where you generate it. Yeah. So these are some of the tools we use. I want to give a huge thanks to Lyft team for building the Proto-C Gen Star, which is the Protobuf processor that we use to generate the code. And then we use the template package to actually template the final generated code. And then some of the other libraries for building the CLI tools itself. Cool. And this is our case study. So 2 years ago, before we had this thing, we had around 10 microservices and we were barely coping with them because they were crashing all the time. And they were written in different styles and there was very haphazard logging. So sometimes there's too much logging that crashes the log system itself. And sometimes there's no logging at all. So that's the fun. And then we built this code generator about 1 year ago. And now we have around 50 microservices. They all use the common library. And we have structured logging now and also tracing. And from that point onwards, we have got 0 errors, 0 human errors in the API layer. And also there was 0 API compatibility issues because both the client and the service code is generated and they can talk to each other seamlessly. Cool. And some of the closing thoughts. So it's basically, I just want to say that as developers, we can all take control of our APIs and we can trust ourselves that we can build it. Yeah. So code generation is nothing like enigmatic. It's actually something that we can all handle. Right. And thank you very much. If you have any questions, please find me after the talk. I'll be here. And we are hiring as well. You can find us on Workable. Yeah. So thank you very much for your attention. Yeah.